Welcome to WebRTC Live. In WebRTC Live, we cover the latest technical topics and business use cases for WebRTC and live video. As always, this episode is brought to you by WebRTC.Ventures, leading integrators of WebRTC video into your custom application.
Welcome to our year-end episode of WebRTC Live. Hello, everyone. I'm Mariana Lopez, COO of WebRTC.Ventures, and I'm excited to host this edition of WebRTC Live. This is a first for me. I'm here to share some insights into what 2024 looked like for us at WebRTC.Ventures, a year filled with exciting challenges and transformative projects. For those of you watching us live on LinkedIn, Twitch, or YouTube, thanks for watching, and feel free to ask questions as we go along. WebRTC has come a long way, from straightforward projects like rebuilding a conference room to really now tackling highly challenging projects that involve complex integrations or require working in adverse network conditions. In this episode, I'm joined by 4 of our technical leaders who will provide a behind-the-scenes look at some of the projects we've worked on in 2024. AI in real-time communications, Lucas Schnoller will show how AI is transforming WebRTC services. He'll share insights into AI technologies and tools we've integrated to enhance agents in WebRTC calls. Then we'll talk to Justin Williams, who will highlight how WebRTC plays a role in video workflows, bridging live interactions and polished on-demand content for creators and broadcasters. We'll then talk about advanced telephony with Alfred Gonzalez. He will explore how modern WebRTC solutions are seamlessly enhancing traditional telephony systems with innovative and web-based capabilities. And finally, we'll talk about communications integrations with Jawad Seb. He'll share how we're enabling robust real-time communications on mobile, even in low bandwidth or remote environments. At the end of today's episode, we will also have the usual WebRTC industry update segment with Sahi and Aaron, so be sure to stick around for that. Today, we'll discuss Gen AI and WebRTC. We have a lot to cover, so let's get started with our first guest. Welcome, Lucas.
Hi, Mariana. Thanks for having me.
Thanks for joining this episode. Lucas, so let's talk a little bit about AI. How have you seen AI used with WebRTC services?
So in this year, we've been involved in multiple projects, one of them using AI through WebRTC connections. The main thing was to create conversational AI bots. And, in this case, we were able to connect to different meetings like Microsoft Teams meetings, and being able to have these bots, basically have conversations with everyone, every participant in those meetings. So that's one of the use cases we've seen. It's really exciting. There's like this new interface of voice. I think is looking very promising in the future. Giving all the capabilities that these LLMs and new AI technologies have, and being able to connect to them through voice, and mainly all of that is done through WebRTC. So yes, these two technologies together are extremely powerful.
That's awesome. Have you seen really any challenges in integrating AI with WebRTC?
Yeah, for sure. So first off, to be able to have these AIs have these conversational capabilities, we had to integrate many different AI technologies together. So there is, for example, the first part of this sort of pipeline is to be able to transcribe whatever we are saying in voice into text, because these LLMs naturally work with text. So the first thing is to use some models that do this in real time. So as we speak, they're very good. They have become extremely good at capturing all the voice, even with background noises or with thick accents or any sort of difficulties, into very good plain text. Then we have the LLMs that process that in real time. We work, with all LLM technology, like adding RAG or context in order to have all the information that the LLM needs to be able to provide meaningful answers. Then putting that together with what is called speech, text to speech. So it's inverse of speech to text. At this time, we grab all that and text that's answered from the LLM, and we transport it into a voice audio that is very real. Like, it really sounds like a human. You can give it like any sort of accent or a type of voice, woman, female, male. So yeah, that process happens in real time. So we need to detect, for example, when we finish a phrase that we're actually making a question, because you're not typing that and pressing enter. This interface needs to understand that the phrase has finished and that is the question that we need to give as input to the LLM, for example. So all of this happens real time, continuously, as you're speaking, and then as you are waiting for the response and you hear the response and then you continue talking. All this process in real time through WebRTC has been a challenge to put together. We went through a lot to also make this being able to be integrated to common tools like Microsoft Teams, for example, that has its own way of processing audio, and so yeah, those have been some of the challenges we've learned a lot from these past months and year.
That's awesome, and it's really interesting how you've coupled the AI agent with the WebRTC processing in real time and making sure that it feels a little bit more natural, those interruptions and those pauses. So that's great.
Yeah.
Looking ahead, how do you envision AI evolving in the WebRTC space over the next few years?
Well, as I said, I think we're entering a very interesting era where now, especially with IoT and robots and other kind of things that we will interact with, won't have a keyboard. So naturally, like, voice will be a very natural place to have that interface, to be able to tell it things, to ask for things and stuff like that. So I think it's very exciting that we will be able to use WebRTC to basically have this interface with these internet connected devices, right? Like, obviously we can think of anything like cars, any kind of device that is not a computer. I think that will be a big one. Another one obviously has to do with the company's customer service and all that. I think right now we're in a space where there's a lot to learn. Sometimes I know many people might have the experience of getting a bot and thinking this is a lot worse than a human. It just gets into a loop and processes are really bad. And that is because we are using old technology with this new technology. So it's new technology in the front, but in the back of that, there's like really old technology. So we're still in the mix of something, but I think there's a lot of potential to bring this to super new levels where this is actually super helpful, a lot more than a human even. Like, it's available with a lot of more information real time. And that is a lot of what we've been working on, to provide all the context that a machine like this one needs to be able to resolve, and also agent capabilities to do tasks, not only give answers, but trigger tasks that happen over the internet. So we're working a lot in this, and I'm super excited. I think it's going to be something huge to continue to develop, and a lot of companies are going to be implementing in the near future.
Yeah, definitely. Lucas, I'd like to take a question from our audience, if that's okay.
Sure.
So Rafa's asking, what impact do you think AI has on scalability and performance of WebRTC applications?
Well, it's a good question. I mean, I guess, you need, in terms of I think, at least in our experience, most of our limitations have been more on the processing that we might need from AI, but not so much on the WebRTC side. Like this, robot joins more than like as a participant, one more participant into a WebRTC application. So of course, if you have millions of users, like in any WebRTC application, then that performance and scalability needs to be handled, but not differently than we did it before. I think the big impact in that is done more on the AI side that is handled aside from WebRTC. So that has been our experience so far.
Thank you. And thanks for joining, Lucas.
Sure. Thank you again for having me, Mariana.
Great. Moving on to our next guest is Justin, one of our senior WebRTC engineers. Hi, Justin. Thank you for joining us.
Hey, Mariana. Thanks for having me.
So switching context a little bit, I know you've been working a lot on video broadcasting and processing solutions. Could you tell me a little bit more about them?
Yeah, for sure. Well, I mean, our stack typically, we're very experienced with React, and we use often open source libraries like Chakra to build web applications, and then we add open source software like Janus or CPaaS for WebRTC integration. And obviously, this has allowed us to build applications very quickly. But now the JavaScript APIs that we have available in browsers today have been really propelling the more complex integrations that we've been building. So a lot of JavaScript APIs in browsers offer many different types of features, particularly around video, among other things, but all of them really enable us to sort of standardize our approach to how we are implementing these solutions and really helping us to move forward a lot more quickly. So we do try to learn about and use the cutting edge APIs and libraries as much as we can. And it's really nice to see as well when APIs move from being sort of experimental to more being stable enough for production applications. For example, with the Insertable Streams API we've used to implement video filters for real-time video chat, we now feel confident in using it for production applications today. And yeah, these days we are building much more enhanced real-time video applications with this types and other types of video processing. We've also worked with a few different ways of broadcasting video to larger audiences. So of course, with content delivery networks, we've had really good success on relying or continuing to rely on HLS. But we are looking at newer solutions that involve using WebRTC to broadcast, which can give us a super low latency, particularly with WebRTC HTTP, WIP, and WEP. We've seen a lot more approaches in the open source community to try to reach very large audiences with WebRTC broadcasting. These are interesting solutions, and some of them use cascading SFUs in this type of manner, but it's largely been mostly experimental for us, specifically those types of integrations. But also for real-time video composition type of features, we've worked on a lot of solutions that use a headless browser with libraries like Puppeteer. And then that also uses the same JavaScript APIs as well as the application libraries that have been used to build the same applications in a headless browser environment. And this solution ends up being very stable and easy to develop on. It works well to iterate quickly and also knowledge transfer to our clients because it's essentially the same libraries and tools that they're using. So we've worked with solutions that use lower level video processing too, like FFmpeg and GStreamer. And with WebAssembly, there's now the ability to use FFmpeg in the browser, which is getting better over time. So we've used this to build video editing applications with processing, even both on the client and the server side. So we're able to move things around to optimize where we see best. And we continue to explore a bunch of other options with WebAssembly libraries, such as MP4Box from the GPAC project. So still tons to learn and explore there.
Thank you, Justin. And you mentioned a little bit about the WIP and WEP protocols. How do you see them impacting the future of video streaming, especially in comparison to older standards like RTMP?
Yeah, for sure. So, I mean, RTMP is quite widely used and adopted protocol for video streaming. The latency isn't overly bad. and it has been integrated into so many different devices and applications that support for it's very common. Even when Flash was around, it made it possible to send and receive RTMP from the browser. This was used a lot, but obviously maintaining the Flash portion was not really the nicest experience. And then Flash obviously was discontinued in the last day of 2020. So now RTMP you can't really stream into browser applications. So with WIP and WEP, that provides both the low latency aspect of WebRTC and the standardized signaling approach with HTTP. It's a lot easier to stream directly to browsers. This lets us integrate video streaming using JavaScript, which everybody's familiar with. And then we can stream from many different types of devices into the browser apps that we built. So open source software like OBS, even GStreamer and FFmpeg have integrated with WIP and WEP. And those are just some of the examples that show its advantages and its adoption so far. So, seeing WIP and WEP becoming available on devices that use to support RTMP may be more common going forward. And we've even built solutions using open source software like MediaMTX that support WIP and WEP to integrate RTMP video into web applications. So we transcode from RTMP to WebRTC with not too much latency added, but hopefully going forward, we won't have to transcode from RTMP and just use everything on WebRTC.
Nice. You also mentioned technologies like web codecs, web transport, and WebAssembly, enabling more advanced browser-based processing. What kinds of features or use cases do you think we'll see in the next few years?
Yeah, well, these are quite exciting APIs, particularly WebAssembly. It's opened the door for all kinds of applications to be built with low-level code. It provides more ability to build tools like video editing, of course, or some type of design tool we've seen. There's impressive tools like Figma or Canva, for example. We'll probably see more leaps in things like cloud gaming and streaming services. With web codecs, decoding and encoding in the browser can allow us to offload computation to servers running in the cloud. WebAssembly offers performance and access to graphics libraries like OpenGL, so 3D rendering can be done well. So we'll probably see a lot of fancy AR and VR libraries, among other impressive integrations built with things like that. But yeah, these technologies are still quite cutting edge, require a lot of work to understand and integrate, so tough to maintain in production applications. However, the ecosystem around them is still evolving. But one of the slowdowns, for example, with web transport, which is the API that's used to integrate HTTP3 in browser applications, there's some slowdown kind of in the Node.js community adopting HTTP3, since Node.js doesn't support HTTP3 very easily, at least out of the box. It's built on top of Google Quick, which changes where transport layer security is implemented. And this change has to be supported by the crypto library OpenSSL, which is used to build Node.js. So in order for Node.js to implement HTTP3, SSL does need to implement support for Quick, essentially. And they've been doing it now for probably over a year. And I think it's in the 3.4, there's better support for it. So hopefully we'll see more integration with Node.js relatively soon. But yeah, until Node.js fully supports Quick and HTTP3, I think a large portion of the web development ecosystem will continue to use HTTP2. But with Google and Facebook, among many others, making full use of HTTP3, we'll for sure see more adoption over time.
Definitely. Justin, we'll take a question from the audience, if that's okay with you.
Yeah, for sure.
Yeah. So the question is, how important are codecs in WebRTC? Is there anything like adaptive bitrate streaming in WebRTC, and can codecs be switched on WebRTC video applications as it is on on-demand video applications?
Well, yeah, I guess with web codecs specifically, that's a little bit outside of WebRTC. WebRTC does have things like adaptive bitrate streaming and stuff built in. And if you were to take the approach using web codecs, you would have to build that yourself. But that does mean that you do have full flexibility to choose which codecs you want to integrate with. So obviously a lot more work that way, but it does give you the flexibility to kind of achieve what you need.
Great. Thank you. Justin, thank you for joining us. It's been great to understand a little bit of what you've been doing, both in the real-time video processing, like adding in backgrounds, and also in the post-processing. So thank you.
Yeah, for sure. Thanks.
Great. Let's welcome Alfred. Hi, Alfred. Thank you for joining us.
Hi, Mariana. Thank you for having me.
Great, Alfred. So I want to hear from you how WebRTC has impacted the evolution of call center technology and some of the interesting use cases you've been working on.
Yeah, so WebRTC integration with telephony systems, in general, it allows you to connect users from multiple sources like web, mobile, or desktop app to users that are connected through phone calls. And this can be seen in like conference meetings where you have people joining from these different sources. And in particular for call centers, it's also really helpful because you can have the agents manage all the incoming calls through their application like web or desktop. And there the agent can receive the call and handle the call, and they can have multiple features in their application like additional customer information. For example, if the user called before, you would have historical data. You could see maybe their case, and you can also have transcription, like real-time transcriptions, or use other AI tools like an AI assistant that could offer you solutions to the customer while you are talking with the customer, and also like other things like analytics, and like it's really helpful for both the customer because they get better service, and also for the company.
Yeah,
And
definitely.
yeah, and there's also that it's more scalable and cost efficient than traditional telephony systems. So that's another thing to consider.
Yeah, it's always great. Lower costs and better service sounds like a win-win.
Yeah.
How do you integrate WebRTC with existing telephony infrastructure?
Yeah, there are different ways, and I can talk about my two most recent projects because they use different approaches. And one of them is open source and the other not. It's a cloud service. So one of them we were using FreeSwitch, but you could also use other open source telephony software like Asterisk. And there you configure FreeSwitch to handle the incoming calls and to connect them to your media server. And you just need a SIP trunk provider where you connect the phone calls, the specific DIDs to your FreeSwitch server or Asterisk or whatever you're using. And on the other hand, we worked on the Connectara project, which we are using Amazon Connect, and which is a cloud service, and they offer contact center service. And there we can route the calls to our contact flows, which is the diagram where you can specify all the logic of your calls. And you could have traditional telephony systems, but in our case, we wanted something more advanced. So we integrated this with AWS Lambdas. So you could process the responses from the customer with the Lambdas function, and you could connect that input to an LLM. So you would have a conversational AI bot answering all the requests. And as usual with Amazon, you have some benefits like scalability and easier and more maintainable than having your own open source software.
Yeah, definitely. Some trade-offs there with already built solutions versus open source. So it's interesting to see that you've worked on both sides of the story, right? What do you think is the future of WebRTC enhanced call centers?
Yeah, definitely I would say AI,
Yeah.
as we've seen with Lucas a few minutes ago. Like AI is already present in many fields, and of course it's affected call centers too. And like you could have bot agents handling the calls directly, and they are really natural and really fast and fluent, as Lucas mentioned, and they are way better than traditional IVRs. They are like in a whole new level. And on the other side, instead of having just bot agents, you can also increase the capabilities of your agent. So they could have real-time insights and suggestions from the bot, or the transcriptions, as I mentioned, or analytics. You could also analyze the intonation or the tone, so you know the emotional state of the user, and you could analyze all that later. And yeah, and also like integration with RAG. You could have a knowledge base document, and you could integrate it with your bot agent and just answer all the frequent asked questions, so you reduce the time that your users usually need, the customers usually need to go through different steps and just to get a really simple answer. And with RAG and AI, you can have this answer really fast.
Yeah. Alfred, I'm gonna take a few questions from the audience, if that's okay with you.
Yeah.
Right. So Jose is asking, what are the typical challenges in implementing WebRTC in a call center environment?
Okay. So there are different ways to handle that, because if you have a call center solution, you could have, like what I said, an open source telephony system infrastructure like FreeSwitch, and on the other side you could have Amazon Connect. So there are different approaches, but yeah, usually you would have, for open source, which is the hardest part, you would need a media server that can connect to your call center solution. So you would need to see how you could manage that. And on the other side, if you are using Amazon Connect, you already have that. You have the Amazon Connect contact panel, and you are already receiving calls in your browser, so you don't need to handle that.
Got it. And related, we had a question about, does WebRTC have built-in features to make regular telephone phone calls?
No, not really.
Right. Those are integrations that you can add in.
Yeah, you could use an open source telephony system like I mentioned, FreeSwitch or Asterisk, and well, it would take a lot of time, so you would need like a budget or time for for developing all that. And yeah, then you could connect your WebRTC media server, your WebRTC application, to this telephony system and just send or receive calls through the telephony network.
Great. Awesome. Alfred, thank you for joining us. Thanks for joining this episode.
Yeah, thanks, Mariana.
Great. And now we're going to hear from Jawad. Welcome, Jawad, to the stage. Hi, Jawad.
Hi, Mariana.
Jawad, I have just a couple of questions for you. What are some of the key challenges in optimizing WebRTC for low bitrate communications?
So for optimizing bitrate for low bandwidth networks, we on the top of the list, we have low bandwidth. In non-terrestrial network, we got up to, in our use case, about 100 kb per second of the upload and download link. And in addition to that, we also had a higher latency. It was nearly 150 milliseconds. So assume that our packet voice media traveling from a user's device to the satellite network, and then the device from the other user coming back in 150 milliseconds. So that was a lot for optimizing the voice. And then in addition to that, we also needed to support the legacy PSTN networks. So it's not just about our applications communicating with each other. We also had PSTN or cellular users that was also able to call to our application, right?
So how did you make sure that you ensured compatibility of your solution with PSTN networks?
Yeah, so essential part of it that on the client side, since we are supporting the satellite communication, we need to put as low pressure as we can on the client side, since the server side could be good in terms of the bandwidth. So what we did is to transfer the media in as best compressed way as we could from the client side to the server, and on the server side what we were doing to transcode it in order to support the PSTN networks. So for the client side we were using, if we talk about the technical term, the Opus narrowband, which was capable of compressing the audio to its max 6 kilobits per second. And in addition to that, we also applied silence suppression, which, so in terms of conversational voice, when one user is talking, so the other would be listening, and when the other is talking, the first one would be listening. So we have a silence period, so we were not transferring any media between those periods. So it helped us a lot with using the Opus codecs to reduce the bandwidth a lot. And once it's reached to our media gateway, which we use SignalWire as our media gateway, it was then transcoding the Opus-based media into the PSTN understandable media format, which is G711 and G729. So this is what we did from our end.
Got it. That makes sense. And while you were doing this, what were some of the biggest trade-offs that you encountered when balancing quality, bandwidth, and latency in your project?
Yeah, so since we applied very aggressive compression on the client side, so it definitely affects the audio quality. So you can't, like we are hearing each other in a very good audio quality, right? So if you hear one of our recorded audio, it's very narrowed voice, but it's still audible. That was the purpose of the project. So we were still achieving the use case, which was to hear the audible voice from the other peer. And then we also applied error correction techniques, like if media packets are dropping a lot, we then again forward some of the media packets in order for other peer to understand what the first user is talking about. And then we also face some occasional media dropouts, like some skipped voice, but still audible quality.
Got it. So some trade-offs on quality. You also had to do a little bit of noise suppression in the client side, and a little bit of processing back on the server side to do some error correcting for that low bandwidth. That makes sense. Thanks for joining, Jawad. I really appreciate all your insights and the interesting projects that you're working on.
Thank you, Mariana. Have a nice day. Bye.
Thank you all for joining us for this special year-end edition of WebRTC Live. As we've explored today, 2024 has been a year of incredible innovation, from the transformative role of AI in everything, including real-time communications, to advancements in video production workflows, telephony integrations, and mobile communications. It's clear that WebRTC is more powerful and versatile than ever. We will now continue with Aaron's monthly WebRTC industry chat with Sahi, where they will discuss the evolution of WebRTC and Gen AI. Our next episode of WebRTC Live will be Wednesday, January 22nd, 2025. We'll have Damien Schnoller, COO of Evercast, join us to talk about WebRTC and spatial computing with Apple Vision Pro. To learn more about our work at WebRTC.Ventures and future episodes of WebRTC Live, be sure to check out our website at WebRTC.Ventures, join our email list, and follow us on social media. Thanks again for joining us today. Let's make it live.
Thanks for joining me today, Sahi. Let's talk about the evolution of WebRTC. This is something you've blogged about before regularly, and I believe you say that we are entering a new era. Tell us about that.
The fourth one. So I think I got into this thing in around 2019. And when I wanted to write something, and then I came with these eras. And the first one was, well, we start with WebRTC, when we started with WebRTC somewhere in 2011, 2012, it was about kind of an exploration process. There is WebRTC, there is this thing. It works sometimes, not always, in Chrome, not in Firefox, but oh, it does, but not together with Chrome in interoperability. That is data channel, that one doesn't. Things didn't work well. So you've seen a lot of people asking, should we use WebRTC? Is that the right thing to do? What happens next? It doesn't work on Internet Explorer. Do you remember that thing, Internet Explorer? So we can't use WebRTC at all.
Right.
So that was the first 4 or 5 years. Then we came into the era of growth. And that's when the question changed of how do we use it? We know that WebRTC is here to stay. It's not going anywhere. It's a real thing. And then Edge and Safari joined into the crowd and had WebRTC support in them. So we all knew that it was time to start using WebRTC. Now, in all of these phases, exploration and growth, the differentiation that we had is just by being first or before others in the market to figure out how to use WebRTC and where to use it exactly. Then came the era of differentiation around 2020, which meant that WebRTC is here to stay. We've used it. We're using it. There are enough production services out there. And now the question is, how do I make my service different than your service? What should I need to do in order to rise above the level of the noise? Because everyone is building the exact same thing with WebRTC. It acts and behaves almost the same.
Yeah.
At this point in time, we had WebRTC 1.0, finally, we had a specification out there. Nobody cared, but we had one. We had Zoom that didn't use WebRTC. They are starting to use it today, by the way. They had some messaging in there that December is going to be a GA for the WebRTC SDK support for Mac or something like that. Then you had to compete with Zoom. So how do I compete with Zoom and differentiate from them? And then we had this minor thing called the pandemic that blew everything, and everyone's now from home, and we're using remote, and remote is WebRTC in many cases. And I didn't think about the fact that, well, it's time to move to a new era in WebRTC, and we're somewhere else today.
Mm-hmm.
And then I said, well, why don't I do what everyone else does? I just call it generative AI and call it a day. Okay, so now we've got generative AI. Everyone is doing generative AI. It's based on LLMs and OpenAI, ChatGPT. But what exactly does it mean? What is the question that we're now asking? And the question that you've seen in the last 2 or 3 months, and this is in the WebRTC Insights all the time, it's what can we automate? What can we do with generative AI that fits into WebRTC? The most mundane thing is, well, let's talk to a bot. Instead of talking to a person, let's put ChatGPT on the other side of the conversation. And instead of sending in text prompts, we're going to talk to him. I'm going to do speech to text, pass it to ChatGPT, then send back to text to speech, and we've got a conversation. So how do we do that exactly? So that's one aspect of generative AI. But I think we're starting to put generative AI almost everywhere in WebRTC and elsewhere. Hence, we now have a kind of an era of WebRTC that I'm not sitting quite well within my chair by saying that, because it's not defined around the word like exploration, growth, differentiation, but rather about the technology, generative AI. And the reason it is done that way, I think, is because nobody cares now about anything else. It's like the whole market everywhere is, if you have AI in your slides, we're going to give you money as a VC. If you don't, we're not going to give you money. No matter how important it is, what it is that you're doing, or how stupid it is, what you're doing with AI. And it just trickled to WebRTC as well. and to the point where we're not looking at differentiation. I don't care how do I make my service better than yours or rise above the crowd, besides if that's going to use generative AI in it, which means using bots and trying to talk to machines and adding summaries and stuff like that. I think that this is where we're headed now.
Yeah. Yeah, no, it makes sense. And it's, you know, you and I have both been involved in the WebRTC space since that initial exploration years. And it's a relief that probably neither one of us has written a blog post about Internet Explorer, certainly, or Safari in a very long time. So that's great to move past that. But yeah, I think Gen AI is certainly a somewhat abused and overused term in a way. I wonder if kind of in the next sort of era will, I think a lot of these labels are going to kind of go away, because in a way, like WebRTC, I guess I would say part of the reason somebody doesn't necessarily care about the technology of WebRTC anymore is because it's stable, it works well, and it's an important part of modern web and mobile applications. And because it's stable and works well, it's kind of plumbing, right? So we still need plumbers. It's still very important for sure, but it's not the glamorous part necessarily. And Gen AI brings some of that glamour, right? But I think there's going to be a phase where, you know, we stop talking about that as a term necessarily too, because it's just there's always some portion of your application that's going to have an element of AI or Gen AI or LLMs or whatever. So yeah, I'll be curious to see what how we refer to that in the future. So, but for now, at least, I guess what you're saying is that we're not going to differentiate anymore based on the communication application itself. The differentiation is all in how do we automate around that, and what aspects does maybe my service automate versus your meeting tool, and how well do they automate them, that sort of thing. Is that right?
Yes and no. We still want to grow, so we're still doing growth. We still want to differentiate, so we're still doing that. But I think most of the focus and the resources and the attention is going towards generative AI in these services, no matter what it is that you're doing. In the education space, healthcare, again, everything with WebRTC, even CPaaS platforms, they're all doing generative AI. I don't recall anyone saying in the last half year that they are doing now bigger meetings.
Right.
More things around live.
Yeah.
If you even look at Twilio, we talked about that. They decided to sunset, then they came back, but somewhere in between, they threw out live. The streaming part is gone.
Yep.
Then they decided, well, if you really want group calls, okay, we'll do it for you. What we're really here to do is customer engagement, one-on-one.
Yep.
I'm starting to feel that this one-on-one is actually one to no one, like one to machine.
Right.
That's what it's going to be. It's not even two people. So I also started thinking to have now 4 different types of services in WebRTC: the one-on-one, group, broadcast, and one-to-machine, which is like, because it's different than one-on-one. And you see this by the type of challenges that we have there.
Yeah.
And I think that this is the generative AI part of it. Just figuring out and understanding what needs to be done there, and the new use cases that this is going to open for the vendors that start using it.
Yeah. No, I agree completely. And I think the one-to-machine type of scenario is an intriguing one for sure. And I think that's the sort of innovation that we'll see in this era of the evolution of WebRTC. And I think is, it's interesting. I mean, one-to-machine right now in most deployed applications would mean like a text bot type of thing, or, maybe there's some audio in there, but we're not far off from doing one-to-machine where there is full two-way video, even with the AI, I think, and I mean, twice this week, I was listening to a podcast for the first time and quickly realized that it was not, it was two bots talking to each other, right? It was one of the AI generated podcasts based off of people's blog posts and stuff. And in a way, it was a nice way to consume that content. In another way, I basically heard the same two AI hosts in both of these. You could tell it was the same service. It's a little bit annoying, right? So for the record, you and I are real. This is real. But nonetheless, it shows that we're not too far off from making those things a little more believable, more useful, more realistic, and with video components to them.
I had a friend that wanted to write a comment on the LinkedIn post. He sent that, and he said, "Should I write this?" I said, "Yes, it's fine." And then someone else said, "No, here's what ChatGPT made out of it." I looked at it, and I got the shivers. It wasn't human anymore.
Yeah.
Which was, if it's perfect, it's not human. That's the problem now.
Right, exactly. Yeah.
You need to strive to make mistakes in order to be understood that you are human.
Yeah. Yeah. Well, and that will bring up, and I think this is an interesting question that, our industry will have to consider, because a lot of the work that Gen AI will be involved in sort of the WebRTC space that we work in will be things like contact centers, more sophisticated versions of bots and stuff like that. And how human do you actually want to make it? And, at what point do you get real humans involved? Yeah. And, I think there is value. I mean, if you're trying to pass it off as a real human, you almost want to add in some imperfection, or just don't pass it off as a real human anyways, and make it clear where those boundaries are. And I think people are okay with that too. Depends on what they're looking for in that particular interaction with the brand, right? So yeah, it's an interesting space for sure. So there's a lot more that we can talk about this, and I'm sure we will in future conversations too. But you also are putting together some workshops around this, I believe. Why don't you tell us a little bit more about that?
Yes, so I'm going to do a workshop around WebRTC and generative AI. Mostly look at the different use cases and map the technology challenges and where people need to look at in order to fix them and solve them. Because if you try to just connect to the WebRTC to generative AI with speech to text, text to speech, and an LLM engine like OpenAI, the end result is going to be crap because it's going to be too slow. So instead of getting something interactive, you'll get something that is still prompt-based, and it's not what you expect in 2025. Mm-hmm. So that's what the workshop is going to be around, and it's going to happen in February.
Okay, perfect. Coming up in February of 2025, and I assume they can learn more by going to bloggeek.me?
Yep.
Excellent. Perfect. Well, thanks as always for sharing your insights with us today, Sahi. To learn more about Sahi's work, you can check out bloggeek.me. And to learn more about future episodes of WebRTC Live, check us out at WebRTC.Ventures. Thanks, Sahi.
Thanks, Aaron.
Thanks for joining us for WebRTC Live. Visit our website at WebRTC.Ventures to learn more about our custom design and development services, and to learn more about upcoming episodes of WebRTC Live.